Okay, hello people watching this video. This is section 4.3, which is dividing, and there's two different ways to divide. The first page or the front side of this has long division. We're going to talk about long division here in a bit. And then on the back side is something called synthetic division, okay? You are going to like synthetic division. You're not going to like long division. I'm just going to forewarn you that long division is more unpleasant. We're going to learn long division today. We're going to learn synthetic division tomorrow, okay? So this back side is being saved for tomorrow. For today, all you have is 3 homework problems, okay? You have a page that looks like this for homework, and it says synthetic and long division practice. You want to make sure that for today's homework, you are on the long division side. And then for the homework tomorrow, there's the synthetic division side. There's 3 problems on each side. You're only going to do the long division. So you only have 3 problems today. Whoa, crazy. Okay, long division is kind of a long process. Okay, you guys have done long division before in like Mrs. Crano's class. And let's just, for practice, let's make up a number and let's divide it by 2. So we're going to take up and we're going to do long division. Like this is what you would do if you didn't have a calculator, access to a calculator. So let's say 1, 4, 7, 9, 3, 8, 1. We'll do that. Okay? Yeah. This is going to be kind of long. It's been a long time. It's been a long time. Okay? All right. So first thing you ask, how many times does 2 go into 1?
0.
Doesn't happen, right? So if you want to put a 0 up top here, you sure can, whatever. Or you just begin with 2 going into 14, right? How many times does 2 go into 14? 7. And then you multiply it back through. So 7 times 2 is 14, but then what do? You subtract it, right? You switch it to a negative 14, and then it becomes 0. And then you drop the 7 down. And then you say, how many times does 2 go into 7? Okay? And it is 3. 3 times 2 is 6, but then you subtract it, and that's 1. Bring down the 9. Am I going too fast? We all remember this process. How many times does 2 go into 19? 9 times. 9 times 2 is 18, and then we subtract it. Okay, 19 minus 18 is 1. Drop the 3 down. How many times does 2 go into 13? 6. 6 times 2 is 12, and we subtract 1, or subtract 12, and we get 1, and we drop the 8 down. And that's 18. How many times does 2 go into 18? 9, and that comes out perfectly. That is 18, but we're going to subtract that 18 and we get 0. And then we have a 1 that comes down. How many times does 2 go into 1? 0, so we put 0 down. And then what? We're not going to go ahead and continue on as a decimal, right? You could if you wanted to. But for now, I'm going to write it like this, which is not what you're used to doing. You usually put 0.5 or whatever. I'm going to put it as 1 over 2, right? Because that's how we will write remainders when we do polynomial division. So that's what that means, right? This is 739,690 and 1/2 is what it would look like if we do all that division, right? Okay. Now, that process is long division. We are going to be doing exactly the same thing, but with x's and stuff. And it's not very much different. It really is not. In fact, this was a long one. You will probably not have ones that are that long, okay, when you're doing the x's and such, okay? But it's exactly the same process, okay? All right, so before we get into the hard stuff, we're going to get into an easy one where you're dividing by a monomial. Do you know what monomial means? Mono means 1. So 3xy, that's a monomial. That's only one term, right? Usually your terms are separated by pluses and minuses. What is this thing up here? That's a trinomial. There's 3 pieces. So I'm taking that and I'm dividing by a monomial, which is kind of nice. All you're doing is looking at these pieces and saying, let's pull 3xy out and tell me what's left over, right? Okay, so looking at just this first piece, let me get rid of some stuff. Looking at just this 6x to the 4th, y to the 3rd, if I take and divide by this guy, what is left over, right? So let's just look at the number first. If I take 6 and divide by 3, I will have 2. If I take x to the 4th and divide by x, I will have x to the 3rd, right? If I take y to the 3rd and divide a y off, I have y to the 2nd. And then I move to the next piece. Okay, let me erase some stuff. Move to the next piece. Now we're doing this one. So I start with 12 and I divide by 3, and that is positive 4. Yep, make sure you put the plus sign. X to the third divided by x is x squared. It's like you're subtracting the exponents. This is x to the first power, y to the first power, right? Okay, you're subtracting those exponents. Y squared divided by y is just y to the first power, just y. Okay, now we start with the other one. Okay, negative 18x squared y divided by 3. Negative 18 divided by 3, we just do the numbers. Negative 6. X squared divided by x is just x, and y divided by y is nothing. It goes away, right? So that's just 6x. This is what we have now, right? It's kind of similar to if you were to take this and find a GCF and pull stuff out, except you're dividing it off. So it does go in the garbage, right? I always tell you, like, don't throw it away, don't throw it in the trash, leave it out front. This time you are throwing that in the garbage. You are dividing it out. So this is your final answer, right? That's it. That's it for that one, okay? That's when you're dividing by a monomial, okay? When you're dividing by only one piece, okay? The rest of it gets a little bit harder, okay? Are you ready to start your division? Boom, we're ready. We can do it, okay? So we are taking this trinomial and we're dividing by this binomial. And let's go ahead and set it up. We're going to put the x squared plus 3x minus 40, and we're going to put it inside, and the x minus 5 goes on the outside, kind of like we did when we were dividing by 2, okay? Do you remember what those terms are called? Like, what's it called when it goes on the inside? That's the dividend. What's the x minus 5? The not dividend.
What's it start with?
D-I-V-I-D-E-N-D. Dividend. What?
What's it start with?
Divisor.
You said
No one here
divider.
is
A
like
divisor.
that.
Divisor. Dividend and divisor. Whatever. The divisor goes on the outside. So there's how that works. Okay. Now, we're ready to go. We're ready to start the long division. Okay. And we do exactly the same process as we were doing up here. Like we looked at the 2 and we said, how many times does 2 go into 14? Right? That's our first question. Okay. So same thing as what we're doing down here. Now, the problem is this has x minus 5. But the rule is that you only look at the x. We only look at the first part and we say how many times does x go into x squared. We're only looking at that stuff. So what do you have to take times x to get x squared?
X.
What do you have to take times x to get x squared?
X.
X, right? So I'm going to put the x up at the top here, okay? And then, what do we do?
Subtract X.
Then we're going to multiply it back through like we did with the x. We took the 7 times the 2 and put 14 down below and then subtracted, right? We're going to take x times x, which is x squared. And at that point, if that doesn't come out to be x squared, we did something wrong, right? We picked the wrong thing. Then x times negative 5. What is that? Negative 5x. We're going to put that right below, okay? Now, before we do anything else, do you remember up when we had the 14? What did we do with the 14? We subtracted it. So here's the very, very most important thing that you're going to forget if you do this. If you make a mistake, it will be this. You have to change the sign, like you're subtracting the x squared, right? But you also have to change the sign of the second piece, right? If that's minus 5x, you have to change it to be plus 5x, right? Because you're like distributing the negative through, right? You're subtracting everything, which means you're just changing the sign of everything, right? Kind of confusing. So here we go. We're going to cancel out the x squareds, and then we just combine stuff. So we have 3x plus 5x, and that makes 8x, and then what?
Minus 40.
Bring the 40 down, so minus 40, okay? And then we begin again. We just start the process over again, okay? I'm going to get rid of my rainbows there, okay? All right, so we look at this x, and we say, what do you have to take times x to get 8x? 8, okay, so I put an 8 up here, and really big pet peeve, don't forget the plus in between the 8, right, and the x, okay? Otherwise, you end up having floating numbers up there. Make sure you put a sign in front of it. It's a positive 8, okay? Then we multiply it back through. So 8 times x is 8x, okay? 8 times 5 is negative 40. But before I do anything else, I have to change the sign. So this becomes a negative 8x, and the 40 becomes plus 40. Oh, look at that.
It's 9.
It comes out to be 0, and it goes in there perfectly. So what's the answer?
X plus 8.
x plus 8. He has no remainder, and he goes in there really nicely. That is my division. Not too bad, right? That wasn't terrible. Okay, I'll show you. This next one's going to have a remainder. And actually, we're going to skip this next one because he's really gross. So we're going to skip example 3. We'll go straight to example... example 4a. This is ugly. Ugly, 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 ugly. Oh, man. Okay, so the dividend is this guy. We're going to put him on the inside. Okay, so we've got, I don't know, x cubed minus 2x squared minus 9x plus 18. And we are dividing by x squared minus 5x plus 6. Okay, so just get him set up and ready to go, and then we'll begin. Okay, same process again. I think this one does have a remainder though, so I'll show you how to write your remainder out. Okay, good? All right, here we go. First, we don't look at anything except this x squared, and we say, what do we have to take times x squared to get x to the third? He needs another x, right? Okay, so I'm going to put an x up top here, and then I start to multiply back through. So I take x times x squared, and that is x to the third. I put him right below here. Then I take x times negative 5x. What does that make? It becomes negative 5x squared. We're not going to change the sign yet, okay? Then take the x times the 6, which is plus 6x, okay? Before I combine them, I have to switch the signs, right? So this becomes minus x to the third plus 5x squared minus 6x, and then I combine stuff, okay? So the x to the thirds cancel out. If they don't, you did something wrong, because that's the whole purpose of it, right? Okay? How many x squareds will you have? 3, right? Negative 2 plus 5 is 3, x squared, okay? How many x's will you have? Negative 15, yeah. And then drop your 18 down, so plus 18, okay? All right, now we begin the process again. Okay, so we start with the x squared, and what do we have to take times x squared to get 3x squared? 3. And don't just put 3, put plus, because he needs to be a positive 3, right? And then we multiply him back through. So 3 times x squared is 3x squared. 3 times negative 5x. This is going to come out nicely. Minus 15x. And 3 times 6 is plus 18. But then I have to switch the signs. So minus. This 15 is going to become plus. And this 18 is going to become minus. Okay, the 3x squared cancels. The 15x cancels, and the 18 cancels. So what does that mean?
0.
We have 0 remainder. He goes in there evenly. So the answer is x plus 3. So if I'm dividing those two things, this guy divided by this guy just comes out to be x plus 3, and that's all. Okay, good? All right. Let's do this last one, hoping that it does come out to have a remainder, because I'll show you what this one looks like. Now, what does this thing mean when it says negative 1 power? Right? If we put this is a fraction. If we make this whole thing into a fraction, it's like this whole thing over 1, right? And to get it to be a positive 1 power, I would move it down to the bottom, right? So I would have x to the 4th plus x to the 3rd minus 6x squared minus 4x plus 14 on the top. And on the bottom would be that x squared plus x minus 2. And really, that's technically to the first power, right? But do you need to put the first power? No, not really. We can just say that it's that guy over top of that guy. But what does this little bar right here mean? What's that fraction bar technically mean, right? That's like a way of saying divide, right? Even in fractions, when you have 7 over 2, that's a fraction, but that really just means 7 divided by 2, right? Okay, so that just means division. So we're going to go ahead and set up our division. Here we go. Let's go over here to the side. We got lots of room. So I'm going to start with x to the 4th plus x to the 3rd minus 6x squared minus 4x plus 14. You kind of have to have a lot of room when you're doing this, right? And then x squared plus x minus 2.
Good thing we have 3 problems.
All right. This is not too bad. Okay. All right. We get them all written out there. There is one more tricky thing that I will have you write down on this sheet because there's sometimes they try to trick you. Okay. All right, good. Okay. All right. Look at x squared. We start with the x squared and we compare it to x to the fourth. So what do you need to multiply by x squared to get x to the fourth power? He needs another x squared, right? Okay, so we're going to put x squared there. And then we multiply back through. X squared times x squared is x to the fourth. X squared times x is x to the third. Uh-oh. X squared times negative 2 is negative 2x squared. Right? Did I do that right? And then change the sign. So this becomes minus, but this guy was already minus, so he becomes plus, right? Okay? Then I cancel things out. X to the fourth minus x to the fourth goes away. If it doesn't, I did something wrong. But wait a second. X to the third minus x to the third. Those cancel out also. Okay, let's keep going. Negative x to the sixth, or excuse me, negative 6x squared plus 2x squared, that is negative 4x squared, right? Okay, then we would drop the negative 4x down. Okay, now here's the deal. This is something kind of funky that happens because we didn't have just one thing that canceled out. We had two things that cancel out, right? So that means at this step, this doesn't happen very often, but at this step, because we had two things that canceled, we have to drop two things down. Does that make sense that we would do that? Right? We have to drop two numbers down. And then we begin the process again, okay? And it's going to look kind of weird because we're now over like in this section, right? Because our middle piece canceled out, right? We're over here in this section. So I'm going to like put like a blank area here. And we're just going to write right up top here in the next spot because we need to hold a place for that one, okay? So we're going to write right up top there. So you have that middle part that's blank, okay? We're looking at x squared in comparison to negative 4x squared. So what do you have to take times x squared to get negative 4x squared? Negative 4. So I'm going to put minus 4, and then I start to multiply back through, okay? So negative 4 times x squared is negative 4x squared, okay? Negative 4 times x is minus 4x, and negative 4 times negative 2 is positive 8, but then we have to flip the signs, right? So this guy is going to become positive 4x minus 8, and then I combine stuff, okay? So negative 4x squared cancels out, the negative 4x cancels out, but I have a remainder. What's the remainder going to be? 6. Is that a minus 8? Yeah, it's 6. Okay, so 6 is my remainder. I always put a box around the remainder so I don't forget him. Okay, and here's how you write the remainder. Okay, just like up above. You remember when we were dividing by 2? My remainder was 1 and we put as 1 over 2, right? Okay, so we're going to put 6 over x squared plus x minus 2 because that's what we're dividing by. Okay, but here's my pet peeve again. You need to put a plus sign in here because it was a positive 6, right? That's kind of weird because we have pluses and minuses going on all over the place. But so there's a plus sign before the remainder. Now, what happens if this was a negative 6 as my remainder? Then you could put minus right here instead in this spot. Oh, I can't. There you go. You would put minus right there instead in that spot. Does that make sense? Okay. So there's how that kind of works out. Okay. Good. Happy with that? So let's write our answer a little bit cleaner. And we can go ahead and mash together that x squared minus 4, right? We can like close that hole up. And then plus 6 over x squared plus x minus 2. Okay? Good? Makes sense? Okay, one more thing that I'm going to caution you on. And I'm going to kind of come up with my, let's see here. Yeah, I'm going to do my own thing over here. Do you guys have room over here in this corner? Okay? All right, I'm going to do one thing here. Let's do one more example. We're going to start this example here, okay? And we're going to say we're taking x to the third minus x plus 6. I don't know. And we're dividing by x plus 2, let's say. Okay? Let's say we're doing that. Okay? All right? Good. I'm going to show you something weird that's going to happen with this problem. Okay, and it's the way that we set it up. So this is my caution to you, all right? So we look at the x and we say, what do you take times x to get x to the third, right? And we need an x squared, right? Okay, so if we take x squared times x, it becomes x to the third power. And if I take an x squared times a 2, it becomes 2x squared. Okay? All right, and then I have to flip the signs. So this becomes minus and this becomes minus, okay? My x to the thirds cancel out. But here I have a problem. Because look at what we're trying to add together. We're trying to add these two right here. Negative x minus 2x squared. Can you add x's and x squareds together?
No.
So what's the problem? We can't add them. So how can we fix this?
Just bring the x, negative x down.
Really the problem is that with this original problem, it was x to the third, right? We didn't have an x squared in the problem, right? And we have an x, this is to the first power, and then we have a number, right? We don't have an x squared. Can I put an x squared in there to make it so it comes out nicely? How do I do that? Let's do plus 0x squared. Can we do that? Right? We have to insert that 0 in there. It was this minus x, minus plus 6, minus 6, plus 6, plus 6. Okay, so whenever you have that happen where they don't go in order and you have a piece that's missing, you do have to put a 0 in that spot. Kind of like when we were doing the quadratic formula and you didn't have one of the parts, it was 0, right? Like B was 0, C was 0, something like that, right? You have to put a 0 in there. Otherwise, your things don't line up, right? I had an x and an x squared here. I have to have this two of the same. Should we continue this problem or not? Nah?
Yes.
Yes? Keep going? Okay, it's not going to be too long of a problem. Now we add that to 0, so this becomes negative 2x squared, and we drop the negative x down, right? Okay, then we keep going. So we say, what do you multiply by x to get negative 2x squared? Negative 2x, right? Okay, then I multiply it back through. So negative 2x times x, it's supposed to be an x. Negative 2x times x is negative 2x squared. And then negative 2x times 2. That becomes negative 4x. And then I switch the signs. Don't forget that. They both become positive because they were both negative to start with. The 2x squareds cancel out. And how many x's do you have? 3x. Are you kidding me? Are you kidding me? I totally made this problem up. On the record, I totally made this problem up. Check it. Ready? Okay, here we go. What do you take times x to get 3x? 3. Okay, then we multiply it back through. 3 times x is 3x. 3 times 2 is 6. Then we switch the signs. I totally made that problem up. You know the chances of that happening and coming out nicely are like slim to none, and I totally made that problem up. Huh! How in the heck did that happen? I have no idea. So if I'm dividing those things out, this is my solution, right? But the key there is if you have a term that's missing, like you don't have an x or you don't have an x squared, you need to put a 0 in there, otherwise your stuff won't line up. Does that make sense? Yeah? Okay, there you go. Happy with that? Makes sense? So all you have is 3 homework problems. Let me show you how this boils down. You want to make sure that you are on the side that says long division. Do you see that right here? Okay, you guys don't have this paper, but you see where I'm talking about long division. Make sure you're on the side that says long division and not synthetic division, okay? Your dividend is this guy. Your divisor is this guy. That's what you're dividing by. And I give you a spot right here to show your work, and then you're going to write your answer in this box. Okay, happy with that? What? No, don't worry about this notation. That's really disgusting. I don't like the way that that's written. But anyway, so just like we did before in all the other problems, you have your division. Let's go through real quick. On this one, do we have to plug any zeros in? Or is he missing any parts? Nope. What about this one? Is he missing any parts?
Yes.
What's he missing?
X to the 4th power.
So this one's going to be a long one. 0x to the 4th power. This one's going to be kind of a long one, okay? All right, don't just go step by step. You have to have nice, pretty handwriting so that you can read it. My boys in here. Eli's ignoring me, but I'm talking to him. Make sure you have good handwriting. You have good handwriting, Billy. Eli, you're gonna have to work on that, okay? Make sure you have nice, good handwriting, okay, so that you can see your work. Otherwise, if you don't know where your minuses and pluses are, because your handwriting's too sloppy, you're gonna get it wrong. So make sure you put a 0 in for the x to the 4th. Anything else that we have to put in for x's for zeros? Okay, let's go down to the last one. Do we have to put any zeros in there? No. Okay, so we're good to go. So that's the only one that we have to plug in. But make sure you do that. What?
So if you get one problem wrong, you get a 66.
No, it's gonna be fine. It's gonna be okay. It's gonna be okay. I give you partial credit for where you went wrong, right? Okay. Okay. How about that? Good. All right. Everybody say bye in the video. And they don't care. They don't like you. Okay. Bye.